And welcome back to part 11 of Basic CNC Programming. In this video you will learn how can cycles are used in a CNC mill program for drilling and tapping. There are several new G codes that we'll go over. The first one is the G81, used for spot drilling, the G83 for deep hole drilling, G84 for tapping with the right hand tap, G73 for high-speed deep hole drilling, and G74 for tapping with left-hand taps. And then the G80 actually cancels any of these can cycles. So let's go over these can cycles and how they're used in a CNC mill program and how to make them work properly. Alright, so first we're going to talk about the G81 spot drill can cycle. As you can see, we have our spot drill going from one hole to the next as it's going 270 thousandths deep and jumps up above the part 100,000 as it rapids from one hole to the next. So let's take a look and see what this code would look like if we wrote it out longhand. Alright, so I got a side-by-side comparison right here between the longhand version of the program and a can cycle version. Now you can see all the code that it would take to jump from one hole to the next, to drill 270 thousandths deep, wrap it up to 100 thousandths above the part as we jump from one hole to the next, and then drill 270 thousandths deep. So you can see that's a lot of code just to do that, and that all can be condensed into a can cycle. And you can see all this does exactly the same thing as what this program right here does, written in longhand. So let's take a close look at this G81 can cycle and see what this means. So we have picked up our tool, we have turned on the spindle, and we're rapiding to our first location where we're going to be spot drilling. Then we're activating the tool offset, and then we're feeding down to 100 thousandths above the part. Now here's where the can cycle takes over. G99 means that between holes it is going to jump up 100 thousandths above the part. So the R100 is a retract plane that's 100 thousandths above the top of the part. So the top of that part that we just looked at is considered Z0. Alright, so we're going to a depth of Z minus 270 thousandths. And then the G81 is the can cycle, which only does a drill straight in and straight back out. And then of course the feed rate is 3 inches a minute. So this line is all the information we need to be able to drill 270 thousandths deep, to come back up to a retract plane of 100 thousandths, and then the feed rate of 3 inches a minute. The coordinates that you see right here are all the hole locations. Remember, we only see an X 2 inches because Y minus 1 inch did not change, so therefore there's no need to mention it again. Inside of a can cycle, when rapiding from one location to the next, the moves will always be in rapid, so it does not want any G1 feed moves inside this can cycle. Okay, so once all the locations are drilled, you cancel it with a G80, and then you turn off the spindle and send the axis home. So you can see the main purpose for a can cycle is to reduce the amount of code necessary to do the same work. Alright, so I have zoomed into the can cycle to take one more close look. The G99 tells the can cycle that as it retracts to go to this 100 above the part, then the G81 means just drill straight in and straight out without pecking. The Z minus 0.270 obviously is the depth, and the F is the feed rate, 3 inches per minute. Then every hole location is listed one at a time, and it will wrap it between these positions, and then when it's through, G80 kicks you out of this can cycle. If you didn't have a G80, then any other coordinate following this can cycle, it would want to drill there. So it is very important that you end the can cycle with a G80. So let's take a look at the next canned drilling cycle for Peck drilling. Alright, so here you're looking at a typical deep hole Peck drilling cycle. And as you can see, the drill stops at 100 thousandths above the part, starts drilling, and then drills about 50 thousandths deep, and then comes back out and clears the chip. So every peck, the drill comes up to 100 thousandths above the part to make sure that the chips clear the hole. So let's take a look and see what the code would look like for this if it was written longhand. So here another side-by-side comparison of all the code that it would take just to drill one hole 1 inch deep using 50 thousandths pecking. Now if you wanted to change the pecking, then obviously you would have to change every single portion of code, because these 3 lines is a peck, a retract, and then rapiding back to 30 thousandths above the previous peck. So you can see the amount of code necessary in longhand writing versus, again, can cycles. So this is the code necessary from here to here to do 8 holes 1 inch deep and 50 thousandths pecking cycle. Now if you wanted to change the peck from 50 to 100, then simply we would have to just change this Q value, and then all the holes will be updated to 100 thousandths pecking cycle. So you can see it would take a tremendous amount of work on this side to update 8 holes, changing it from a 50 to a 100 thousandths peck. So let's close this program and let's take a closer look at this program right here, and let's zoom into this can cycle and let's go over the details. Alright, so in this G83 can cycle, the G99 tells the can cycle to retract to this R value, which is 100 thousandths above the part. Now if you wanted to change that, then the retract value would be 200 thousandths above the part. So it's just that easy or simple and quick to make a change to the values of a can cycle. The 83 is the can cycle for deep hole drilling with pecking. Now the peck is controlled by the Q value right here. Right now that is set at 100 thousandths, but if you wanted to peck at 250 thousandths, then it's just that simple. So every hole that you see here, or every location where it's going to drill this -1 inch deep hole, will be pecked at 250 thousandths. Now if you needed to change the depth to 1 inch 500, then it's just that simple to update every hole. Now every hole that you, or every location that you see right here, will be updated to these numbers. So make sure that if you're making a change, that you're affecting every hole that you have listed right below it. Alright, then of course the feed rate is 3 inches, and if you can slow that down or speed that up, of course that will affect every hole again. So the G80 cancels the G83, and that covers the G83 can cycle. Alright, so the next can cycle is G73. And take a look at this. You can see it's not retracting to the top of the part, but it is backing up just a little bit just to break the chips as it's feeding down inside the hole. So let's take a look at this can cycle. Alright, so as you can see, this can cycle looks exactly like the G83 can cycle. So the only difference here is that instead of the drill after each peck retracting back up to this 100 thousandths above the part, it just backs up a little bit each time just to break the chip, so that the chips don't get all long and bird nest around the drill. So that retract value is controlled by a parameter in the machine that can be changed, but that parameter is going to be different for different machines. The value that's in there probably works for most applications. Alright, so let's take a look at the next can cycle for tapping. Alright, and here we're looking at the G84 tapping can cycle in action. We got a right hand tap, stopping 100 thousandths above the part, tapping the full depth, and then once it's reached full depth, the spindle reverses, and obviously all this is very timed to make sure that the revolutions in the feed of the spindle is perfectly timed. So let's take a look at that code. Alright, and we're looking at the G84 can cycle for right hand tapping, and as you can see they all look very similar. The G99 again means that the tap is going to retract to this R100 plane as it rapids between hole locations. The G84 is the can cycle call for right hand tapping, and the Z-750 is the depth of the thread. So all these values can be changed as far as the depth and the retract value. Now the feed rate on this is pretty much locked in because it is determined by the RPM and the amount of threads per inch. So this is a calculation that we're going to go over real quick. In this example we're using a 1/2 inch 20 taps, so that means that for every inch we have 20 threads. So we're going to have to figure out what the distance is between each thread. We take 1 inch and then we divide it by 20, and that means there's 50 thousandths between threads. So then we multiply that times the 300 RPM that we're going to be running this tap at, and therefore we come up with 15 inches a minute, as you can see in this example. So we cannot just arbitrarily put a feed rate there. This is definitely a calculated and very important for the timing of the spindle and the feed as it feeds in and out of the threaded hole. Alright, so the only other thing to remember is that for a right hand tapping cycle we need to turn the spindle on clockwise, so therefore in M3. Then of course the G80 at the end of the can cycle to make sure that we cancel the can cycle. So let's take a look at the G74 can cycle for left hand tapping and the minor differences between the two. Alright, so here you're looking at the G74 can cycle for left hand tapping. Basically looks identical other than it's a G74 instead of a G84, and we're turning the spindle on counterclockwise instead of clockwise, so make sure you got that M4 in there. The calculations for a left hand tap obviously are the same to come up with the feed rate, and make sure that you always end the can cycle with a G80. So that ends this video on can cycles. Thank you for watching, and we'll see you in the next one.